we're going to play around with making complementary angles. So I think the easiest way to do this would be with the angle of a given size tool. And there are many other ways because there's so many different tools here. So I'm going to choose that one. So the way it works is, again, when you click on it, it tells you select a leg point, select the vertex, then enter the size. And by that, they mean the size of the angle. So the vertex is going to be the second click. So if I start over here on the left and I go over here to the right, it's going to make that angle coming out of that second point B. So here I said, let's see, angle of a given size. I'm going to leave the degree symbol there. That's important. Change the 45 to a 90. And then what do you think it's going to look like counterclockwise? I'm going to cancel this for a second. So I have A here, and then I clicked B second. So this is a point on the leg of the angle. That is the vertex point. Which way is the angle going to go? So it's just kind of a fun play around, get your orientation about clockwise and counterclockwise, which I have almost as much trouble with as left and right. So A, B, 90 degrees, leave the degree symbol. Suppose I leave counterclockwise. Okay, so it went down here. So B was the center, so it's measuring the angle from A, centered at B, down to this point they're calling A, and that single quote there is we usually call it a prime. So that'd be A and A prime. So it went counterclockwise to get down there. So now I'm going to throw some rays in here, centered at B to A, centered at B to A prime. So now I have a 90-degree angle for sure. So any other ray I make coming from B out into this 90-degree angle is going to allow me to make a pair of complementary angles. And so then I can measure them to check them out. So now I'm going to switch to the first angle measure tool, which just measures whatever's there as opposed to making an angle of a given size. So you have to distinguish between these two tools. So there, the key is just make the vertex the middle point that you click on. So I want to know what is angle A, B, C here. And again, things are getting a little muddled there. So I need the move tool to clean it up. Okay, so I'm going to put the 90 out of the way there. So it's telling me this angle is about 54 degrees. Is it exactly 54? No, but it's close enough. I think the angle tool usually will go to the nearest 10th. So this is to the nearest 10th, close enough to 54 degrees here. Again, I can color code those. So with the move tool, if I click on it again, it should offer me to change its color. So I could say, hey, let's let you be green. All right, then I want to do this other angle there. So to measure that one, I go back, get my angle, plane angle measure tool, and I would click C, B is the vertex, and then A prime. And it says that angle right there is 36. It's kind of hidden. So grab the move tool, reposition it so you can see it. If you click on it again, you should get to change its color. So maybe I'll have red and green there. So it was designed, right, because I put this out of the way. I put this ray BC right through that 90-degree angle. So the two angles it split had to add up to 90. And if we move point C, what we'll get is a different variation on it. So 54 and 36 are supplementary angles because they add up to 90. If I take point C and I move it anywhere else, and again, notice it's giving me answers to the nearest 10th. It's hard to get just whole numbers randomly. Oop, almost had them. Oh, there we go. 29 and 61. Otherwise, I have some number to the nearest 10th. 36.3 and 53.7. If we add those up, we should get 90 degrees. And again, if two angles add up to 90, they are called complementary angles. I think I accidentally said supplementary there at one point. I'll explain that next. Questions on playing with GeoGebra here? Okay, supplementary angles next.